So guys, welcome again to our Cairo Bootcamp. This is the third section. Last week we went through Cairo program, Starknet contracts, data types in Cairo, and also we had Oluwatosin Sarah go through um, Starklin's exercises. So today we'll have Sisi put us through on how to write our first Starknet contract. So we also as well go through build a simple ERC20 token. And yeah, so Sisi, are you there?
Yes, I'm here with you, boys.
Cool. So
Yeah.
you have the floor.
Okay. Welcome everybody to another section of the bootcamp. Okay. Today is session 3, which actually country cousin. So we are going to walk us through on how to use Katana and also use Starknet, to deploy our smart contracts, and as well we try and do some interactions with what we've done. Last week we were introduced to Cairo and the syntax, so the data types and everything about Cairo, what Cairo program is all about. That was that for last week, and also we solved Starknet, right? A very, very wonderful way to get started with understanding Cairo. So today we are going to explore contracts, as opposed to Cairo programs. The contracts have storage, and can change and mutate states as well, and they have access to the VM. So I have a very few slides here. So I'll begin to attempt to share my screen right now. So we can just rush through it, and then we move on to building a simple ERC20, contract. So okay. So desktop one. Share. Please confirm if you can see my screen when it comes on.
Yeah.
Okay. 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 Thank you. So we have this. This is where we start. This is about introductions. Then the agenda for today is we will get to understand what declare and deploy means, what invoke and call is all about, introduction to Starknet, and then I'll talk about Katana. Then I'll talk about low-level calls. This is all about how to interact with another contract, okay? And then build our token. So moving on to the first part of declaring your contract is just like a way to submit your code to the network, right? You've written your code, that's your smart contract, obviously, and then what you do is you submit it to the network, and in return, the network gives you an evidence that yes, you actually submitted something, and that's called class, the contract class hash. Now, with that particular evidence that you submitted something, you can be able to deploy the contract, right? And that's what deploying is all about. And invoke and call. Now, from some of us, with Solidity background, there are function visibilities. For some functions can change state, and you get to pay gas fee before you can, call those kind of functions. Now, whenever a function is an external, I'm talking about Starknet now, and you get to like pay gas fee for it, you can change the state. You are said to be invoking that function, right? Because you get to pay because the transaction, and it changes the state. But when we talk about call now, call is just like read. You're reading only, you're not changing anything. So you don't need to pay anything like to carry out this kind of transactions. And the interactions you are actually carrying out is obviously with what, the functions within your contracts. All right. The next part, introduction to Starknet. Now, Starknet is like a CLI tool, okay, for interact Starknet. Now you get to deploy, okay, got the notification. So you get to deploy your contracts with Starknet. It was written in Rust actually, and then now if you don't have it installed yet, this is like the command you need to run, and it's that straightforward. Just run this command. I don't know about Windows users, but if you're Mac and Linux, you should be fine. And then after this command, you run this other one, and then you'll be up. Then to confirm your installation, of course, you can use this guy here, Starknet the version. So I will try, and I think I have it installed already. So I'll just run the version, and so we have Starknet, go to version. See, I have 0. This installed. So once you have it installed, you get the version as well. Now, after that, we talk about Katana. Now, Katana is like a local development environment, okay? And it's just like what Hadat offers. In Hadat, you can also deploy your contracts to local Hadat node. Well, so it depends on you, the design, the developer, your choice. Now, Katana it was developed by Dojo team, right? And is used to like everything you can do on the DevNet, even mainnet. You get to play around with it on the local environment and see how it works. So to install Katana, you use this particular command here, right? Then you dojo up. Alternatively, you can compile from the repo using what we have here, right? So anyone that is okay with you, that you feel like you're comfortable with, you can. And in the end, you also confirm your what is it called? Your installation using Katana version. So if I check mine, I think I should have it installed as well. Now we are going to need these two tools actually. So it's important to have it installed in case you don't have it installed before now. So you can see mine, I have Katana, 0.2.1. And okay. Then the next thing we have to look at is how to interact with different contracts. Like if you have contract A, how can you interact with another contract? So we have now, once you've written your contracts with its interface, this set of guys, dispatchers, they're called dispatchers, right? They get generated for you automatically. Now, using an ERC20 for an example, which that's what actually we are going to look up today eventually. So if it's an ERC20, you get a dispatcher like this. That's the contract dispatcher. Now we have two of these dispatchers. We have the library and then the contracts. Main difference between these two is that with contracts, you are interacting with a contract, like the contract address is what you are interacting with, right? So, but with the library, you are using the class hash of the contract you declared. So we are actually going to, like, do these things practically in the end, and see how it works. Any other thing here? Yes. Also, the compiler generates a trait for you, a dispatch trait. Now this trait kind of allows you to, run interactions with the functions contained in your contracts. Okay, so if function A is trying to interact with function B, function A needs to have access to the this partial trait before it can interact with the functions contained in contract B. So I think at this point, it's time to, like, get started with building. Now I'm not like a fast type. I don't type fast, okay? So as opposed to, like, typing the whole code out and then coding along like live class, I decided to, like, set up a repo which we are going to use, and we still feel good about what we're doing. So in that case, in that scenario, we get to focus more on writing and understanding the contract and every other thing that goes with it, as opposed to, like, writing everything and then end up wasting time. Maybe you might not even achieve what we set out to achieve. So now the repo is there. So I'm going to, like, create a link and I paste it in the group chat so that anybody that wants to code along can join up, and then we groove along. So I'll open for me personally, I'll be navigating to my desktop. Okay. So I should clean this out. Okay. All right. This guy is interfering with my view. So I then open a terminal, So git clone, git clone, paste, and extract the files. Okay. So I then cd into the file that's like Starknet something. All right. Enter. Attempt to open my VS Code. All right. We'll give it a second to load up, and we'll continue. This. Okay, so whenever you want to write a smart contract on Starknet, like we said, the Cairo programs can be contract as well, right? Except now they are giving something called the storage, and they have access to the VM. So you have to head over to your these are like, I have like 3 folders here actually. And there's something called scab.tm, turmoil. I guess that's what it's called. So you need to, like, put in your dependencies here. Starknet, this actually helps the compiler to understand, okay, what we are doing at the moment is what a smart contract, as opposed to writing programs. Remember, in programs, your point of entry is usually the main function, right? But here, there's no main function. Now, if you want to get this version here, I think once you have scab installed, you should have it installed as well. So you want scab, save version, So see the Cairo version we are using. Cairo version usually tallies with the Starknet version as well. So you put it here. Now this guy kind of directs our artifacts and the Sierra intermediates of our contracts. So it gets located in the targets. When we compile, I think, yeah, I don't think it's here at the moment, but when we compile a contract, the target folder gets generated for us as well. So in all of your contracts, you ought to have these two at least for you not to run into a compile time error. Now we have like 3 folders here. The first one we have to get started with is actually the ERC20. I have it like right here. And so, okay. Makes everything white. Okay. So before you can write, you have to get started with our contract, of course. I mean, we are all familiar with ERC20 by now. Like, I don't think it's kind of new to us. So we are not going to like spend much of our time like explaining what these functions does. Rather, we are going to like see how to implement them and then ask our questions accordingly as we go on. So first thing you have to do is to make your import the Starknet. This is how you import, right? This is how you import from Starknet, you import your contract address, right? And then if you want to specify interface, you use the interface attributes. This is called interface attribute, right? Then the traits. Now, within a trait, you have functions that have just the function signatures without having the function bodies. So you can see the bunch of functions we have of the get name, get symbol, and the rest. They just have the like component and the returning values. The values will get to return. And if you look closely, you see something going on here. Right here we have this thing art symbol. That's like, it's called snapshot symbol, right? So you're taking a snapshot of the contrast state. And that's the name of our interface, which takes in a generic type. The generic type is what? Contrast state. That's this guy here. So contrast state like gives the variables and everybody within the contract like access to the storage, right? So whatever that is within this smart contract is contained in the contrast state. Now, so these functions like get name, symbol, decimal, total supply, balance of, allowance are all like, talk about read only. They can't write to the state because they are taking snapshots. But when you use reference, like we have here, reference gives you the ability to like, change state, mutate variables. Okay. So, right, someone's mic is unmuted. Do you want to speak or something? Okay. Pablo, do you want to speak or like? All right. So back to this, for you to start your smart contract, you use the attributes. So you can see the difference. This is Starknet contract. It tells the compiler, okay, this is a contract, right? As opposed to here, we have an interface. This tells the compiler, this is an interface. And right here, we have a contract. Now, in Solidity, you use contract, the name of your contract. Here we use mode, like, it's like a file. And then the name of our contract is what? ERC20. And right here, we have the necessary imports, contract address, caller address, which is like, talk about MSG.sender, right? That's MSG.center, usually it's like a global variable if you're working with Solidity. Now we have our contracts address const, like it's zero address, similar to this. Then zeroable, like zero address as well, but in another version. Now you can see we had to import our trait from here using super keyword, right? So like this file here to this end, and this guy from here downwards are two different files. So for you to access what is up here, you need to use super and then the name of what we have here. Next thing you have to specify is the state storage variables. And storage variables, you must include the attribute as well, right? To tell the compiler, okay, this is our storage variable. And in Cairo, in Starknet, you declare your storage variables with what? A storage struct. It must be this name, please. It has to be here. If it's not here, you are probably going to get, see that? So contract must define storage struct. So we have to take it back to what it is, and everybody will be happy. So right here we have the things our token will take. In the name of the token, the symbol, which is felt 252 decimal U8. Then total supply is of type U256. And we have a map, legacy map, just like you have mapping, you are mapping contract address of a certain balance to a certain amount eventually. And the allowances here is containing like two addresses. I talk about the spender and the person they are allowed to like spend, the owner and then the spender, and then the amount we are allowed to spend. You can see it's like similar to what we have like 2D mapping here as well. So we're mapping actually a tuple of addresses to a U256. Next up, we have the events. So the events also, we have to annotate it using the event attribute, right? This. And then another annotation we have here is like we are trying to derive some traits. Now in Cairo, we know it uses ownership to manage, this kind of variables. So every variable must have an owner, and it has to be one person, right? So we can either borrow from that guy or we can use it. And when you are using it, like when it moves, you are responsible for what? To clean the system, to drop it. And that's why we're deriving this guy here, this trait, derive the trait, drop, so that whenever it's borrowed, after usage, it gets dropped. And then we have, another trait here, like we're stating that this is an event. So within an event, now your events in Cairo in Starknet must be what? Enums. And the name goes like this. So it's like a rule, right, that you have to follow. Then in our contract, we are aiming to emit approval whenever an approval function is approval is carried out. We want to emit an event, and when transfer is carried out as well, we emit an event. So you can see the type here. This is like the name of your the field, and then you have the type. The type here is also a struct that is undefined somewhere, which I will bring up right about now. Approval is down here. So right here you have the derived drop as well. This derived drop works once you have like a struct or enum. Okay, so ownership, there has to be someone that owns it, and the person that owns it after usage is responsible for cleaning. So we have the trait up here. Then for our transfer, the type here, we also have from is of type what? Contract address. To is also contract address, and then we have the value. Then down here, the same thing applies, contract spender, and So move on to the constructor. Now, constructor is not usually not part of the interface, and also like I had to like put this comment here to help us understand what's going on. So internal functions also are not part of the interface we have here. Reason is because this interface at the end of the day gets like exposed to the real world. Someone elsewhere can actually interact with this interface, the function within the interface. Okay, so within our constructor here, we're taking a reference to contract state. Already talked about this. This gives us like the state of the contract at any point in time, right? And we're referencing it to itself. And we have the ref keyword. Remember what I said earlier? Whenever you're using ref, it means you're borrowing. And when you borrow, the function will now have the ability to like change the variables. So we pass in a couple of parameters here. You can see the name of the token. We're trying to initialize these values here, right? At the point of deployment, of course, we know what constructors do. These are things like passive, they get to run once. At the point of deployment, you supply the values here, and that's it. So after this, we come down here, we have to assert that the recipient, the person that the token will be sent to, is not a zero address. And you can see the logic. I think in Solidity you use require, right? But here we are using assert. So assert not, right? Not provided is not, the recipient is not zero. So without this exclamation mark here, this becomes the recipient is what, zero. But once we have that, we're excluding this guy, else we are transferring to zero address, and that's not actually what we intended to do. And here we can see how to write to these variables here. So to write, you say self, that's this guy here. We're making a reference to this guy, dot name. Name here is what? The name we have right here from our storage variable. And then dots, we write whatever that is here. Remember this, like our parameters. So we write name and symbol dot symbol. So everything in our storage, like we already said, is contained within what? This contract state. Yeah. So we can easily access it from wherever we are within the contract. And so we have the decimals, of course. You write the decimal, this guy here, accordingly. I believe this is straightforward. Then after, because there's a transfer that will happen here, right? So we need to emit the event because someone will receive the token, that's the initial supply that we have here, right? From the zero address. So, and then, so we emit the event accordingly. Next thing we have here is like external functions. This is how you annotate it. Now the V0 here is like telling the compiler, okay, this is exactly the particular compiler we are to use for these particular contracts. Okay, so right, somebody is in the waiting room. Okay, so now every functions within the external kind of scope is visible to the outside world, right? So it means anybody anywhere can call it. So within here, we have the read and write functions, everything stored up in here. So, and it's usually done using implementation block. Reason because we already have the traits implemented up here, right? So we have this set of traits, and the way it works in Cairo is this. Every function here must be implemented in your implementation block, else it throws an error. So we have this set of functions here. We start with get name. Down here, we have the get name function, just the way it is up above, right? the way it is, and it's returning a thought 252. So down, we are reading, look at that again. Once you see this in a contract, just know that is a read only, right? That we're not writing anything. This function will not write to the state. It will only read. It's called snapshot. We're taking a snapshot of the state of the contract state. Now, what we intend to read here, and it's going to return what? If 252 is the name of our token. And now, normally you can terminate the process with the semicolon, but since we are expected to return a value here, if you omit the semicolon, the compiler automatically returns the value for you. And the same thing applies to what we have here. Give me a second, please. So same thing applies to what we have in get symbol, right? So we are reading from the contract storage here. You can see that symbol. This particular symbol is from the words, our storage up above here. And okay. As usual, there's no semicolon, it means it gets returned automatically. Here we're reading the symbols, so they're like similar pattern, nothing strange here. And up onto this place, we are reading the balances. So all these functions, they're taking snapshots, they don't make any change, they're just reading only, read only, read only. And here we are reading an account, balance of an account. An account is what? Of type contract address that is passed in here. Then this other guy, the same thing. Then our transfer, before you transfer, of course, you have to pay for the gas fees. And so you make a reference to self as opposed to taking snapshot to the contract state. We're making a reference now. We're borrowing. And then first line of code here gets the caller. You can think of this as, I think I already said it, the msg.sender, the person calling this particular function. So your address is what we captured here. And then we are using, self.helper transfer. And this guy here was captured within caller, right? And then down here, we have our contract state already. So we can easily read this helper function here is defined. It's like an internal function, right? And it was defined somewhere down here. So you can see that from this 148 downwards, we have another a trait called, like an attribute called generate trait. What this does for you is it's like, okay, is that like question in the chance? Okay. Okay. So what this generate trait does is it generates interface automatically for you, right? As opposed to what we had earlier, here we had to like write our own interface manually, right? But in this case, these are like internal functions. Internal functions, outside world cannot actually interact with internal functions, right? So there's no need including them in the external implementation block up above. So that's why we have it down here. And we can see our function transfer. It takes reference to the contract state as well. We send that as the person trying to transfer, and then the recipient type contract address as well, then the amounts they want to transfer. First of all, we carried out some sanity check here to make sure the sender is not a zero address like we did earlier in the constructor above. And also the recipient is not a zero address. Then once that is set, all we have to do is update the balances. So from here, we are reading, self.balances. Then we're writing whatever the person that's sending, that's the sender here. And here we read the balance, right? This is the current balance the person has. They will minus the amount they want to send. Down here, we update the recipient. That's their balance, right? So we get it from the storage as well. We write what everything, like everything from here to here. So here's the recipient. We get whatever his current balance is, then we add the amount that was sent to him. And yeah, that's about that. And once that is done, we emit an event. This is the syntax. Self.emit, then you put in your values. So like I had to come down to explain this function here because we were talking about this guy up here. So we pass in the caller. The caller is actually the person that will make the transfer, right? And then the recipient, then the amount they want to send. Transfer from, same thing applies. We get the reference to the contract state because we are going to change something, right? And then we get the caller, person calling the function. So you can see all of these guys that make changes to the state. The get caller address is like common among them. So you must have someone that's gonna pay for the transaction. And so I think that's about that. Then spend allowance. Okay, the person, okay, now we have another like spend allowance. Let's see where it is. Spend allowance, like this function is actually very, very crucial. I think we can understand what's going on here in our proof helper. There's nothing much here, just your sanity check, then update the balances as they go. Now down here we have spend allowance, which takes in the contract state as well. And then the owner, that's the person that wants to like, approve the allowance, and then the spender, then the amount. First of all, we get the authorized amount the spender is allowed to spend, and that is what we did here. And it's stored in a variable current allowance, right? Then here we defined a variable that's of type U128. Now in Cairo, U256 is not supported at the moment, right? In Starknet, actually. So to achieve U256, we have to do is like combine that is this guy U2128 like into two places. You have the low and the high. Let me show you like an article here. Maybe that might help us understand better. So this is it. Like this is the entire this picture here. I believe you can see my screen, please. This is the entire 256 bits. Then it's divided into two, and we have a struct. It's like within a struct, low and the high. So it means if we bring whatever that is value from 0 low to what the highest that 128 can take at some point, then here also we bring it up. Combination of the two will give us U256. So right here now within our contract, we are trying to like check for something, right? Because someone cannot spend this amount. I mean, for if you check the type, the highest value a U8 can take, for example, now, U8 as unsigned integer, 8-bit unsigned integer, right? The highest value it can take is, I believe it's 255. So, but there's no way like to check for this in our Starknet at the moment. So what we had to do now in order to get the highest value that can be allowed to be spent, we use this variable here, and then we say the current allowance dot low. So dot low, we are referencing to what this guy has here. Let me show you one more time. What we have here dot low, and then we're saying it has to be equivalent to this variable we defined here as once max. And there's another operator here. the high. So remember, to get U256, we had to combine two values, right? It's like concatenation of two values. Two values that's 1 to 8 unsigned bit integer. The two of them were combined to achieve 256. So right here, we are combining the two, both low and high, and we are saying it has to be captured within this particular variable. Now to check before we make the transfer and approve, if it is not this value, because this is like the maximum value you can ever get, and it's not like logical for someone to say they want to spend this kind of amount. If you check the equivalent of when you type this out, max of this is very, very massive number, like a very, very big number. So it's not expected someone will have this in their wallet or something like that. So once this sanity check is confirmed, then the approved helper, we subtract the allowance from the person that's the owner, yeah, subtract it accordingly, and then it gets spent. So I don't know if we have any kind of question as opposed to what we've just run through. In the absence of any question, we will progress to like deploying the contract and then run some interactions, and yeah, move on to trying to run inter-contract interactions as well using dispatchers. So do we have any question at this stage? Okay. Thank you. Thank you. So within our the slide, I have a very, very like a quick setup process to deploy the contract, right? So that whenever you like feel like want to deploy, you can easily follow these basic steps as opposed to stressing yourself. First of all, you need to start your local environment, right? So I can do that anyway. I can say Katana, then I'll need accounts. I use the flag for accounts. Accounts, I need like 3. Let's use 3 accounts, and I run enter. So this actually generates some set of funded accounts for you. You can see them. They are funded along with their private keys, and and it gives you the RPC, of course, to work with. So this is like your local RPC. You don't need to be online for this to work. So next thing we have to do is we get, like I said, we follow this guy I have here. We create a signer, the person that will sign our transactions, right? So we do that. We create a key store. That's like a safe place to store all of our credentials. Now to do this, I need to navigate to a particular folder that we're working with. And currently I'm on the ERC20 directory. So I say CD ERC RC, get enter. I think I'm in already. Then ls, yeah, that's the right place to be. So I run this command. So Starknet, that's the Starknet. I believe we all have Starknet installed right now. Signer key store. Then from key, this is the name that we will see after a minute. Let's run it right now. Enter. You enter your private key. Now, how do you get your private key? You get your private key from Katana, all right? So let's use this first private key from here. I copy this particular private key. I move on to this other place, and then I enter it. Now, when you enter it, it won't be visible, right? But just hit enter, and then enter your password. I enter my password, and let's see what happens. And now you can see we have a new file generated for us here. account 0.keystore.json underscore. Okay. So that's this name here, that guy here, I just got generated for us up here. Now for this public key ends with 100, 153, right? So if we go back to our Katana, I believe that is this guy here. So we've been able to like create a signer. Next thing we have to do now, still using our cheat sheet, go over to next we fetch the account that we just account we just created right now, and you do it using this particular command right here, Starknet account fetch, the smart wallet address, and then the RPC you passed. So I go back to where I am and I will get to the second, then I paste that command. So right now I need to update one or two things, and one of those is this guy here. I delete smart wallets. I go back to my Katana and I copy the account address. You can see that. So I copy this account address, come back to this place, and I paste it right here because that's what we want to fetch, right? And then when we fetch it, we want to output it as account.this, account 0.this. So we're expecting another value here. It's like the account we use in our deployment and every other thing. Oh, I have a mistake somewhere in my stack line. It says stack line instead of S. So corrected that. So yes, it gets generated for us somewhere here. And yeah. Next thing up we have, okay, I think we have some chat. Let me see. There's a question there. Okay. Thank you, Francis. So right here, we already did this. Sorry. We've, fetched our account. Next thing is to declare the contract. Like we said before, to declare contract, it's all about submitting our code to the network, right? Yes. So we start from here, go down. And of course, we need to like populate things accordingly. Nope, not you. Go back to VS Code. I paste you, and yeah. So right here, we go down all the way to, this place that has ankle braces. Relocate. I'm trying to get our Sierra, the intermediate kind of compiled version of our contracts, right? Now to get that, all we have to do, we didn't do something actually. We ought to compile our contract before we can have access to that particular what is it called? The JSON. But okay, so sorry about that. We need to build our and make sure it actually compiles. Yeah, before we can actually do anything that's on our mind. Can I cut this? Okay, just copy. Clean. All right. Okay. I can clean you from anyhow. So we need to use Scab, our package manager, Scab build, right? So let's see what it gives. Hopefully everything should be fine. Hopefully. Yes, our contract has been compiled, and now we have this access to, we have this target file here, and then go deep into dev. So you see another two set of files. If you hover over one of them, one is an artifact. This is the artifact. That's not what we need. What we need is this guy up here, the class.json. Okay, so I'll go back to our cheat sheet, copy this command right here, right over here, and I'll paste the command one more time. I will copy the part of this guy here. I hope we are following. I'll go for the copy relative parts. And then right here, I'll go all the way down to this place. Okay. So I'll paste that particular part. So like so. Now I believe this flag is the RPC we are working with, and that's the Katana RPC we know here. So you can see it down here. I think I showed us earlier. That's this guy here. So then the account is the account we created somewhere here, right? This account here. Then the key store, that's another flag here, is the key store we have from here. All right, so after this, we hit enter, hopefully put in your password, hopefully everything works, okay? So far, we've successfully declared our smart contracts. Now, if we go back to our cheat sheet, I think here, so the next command we now do is to deploy, right? So after the declaring, you can deploy, and you deploy using what? The class hash. So if I should copy our command right here, so this is like hassle-free. Take it, I go all the way to this guy, I paste it here. We're trying to deploy our ARC20. Okay, I have a shot. Let me check it out. Okay. Okay, no questions. All right, so we need to update what we have here. And looking at the transaction of our last, you can see the class hash down here, right? This is the class hash. So we copy this guy here. Accordingly, go down all the way to this guy. Yeah, not me too fast. Class hash, we replace it with class hash we have up above. And then, yeah, remember at the point of deployment, you need to pass in the, if your contract has a constructor, you have to pass it in, the values, you have to instantiate them. And that's what we are going to do right here. Okay, I can see a possible error coming up here. So let's take care of this. So we have to look up our, so please, if you're using this, our cheat sheets, be mindful of these, the flags. I think something happened and it's not what it was meant to be. Okay, so to pass, because our contract here has, it has, constructor rights, and we are to instantiate these values here. The name of our token, symbol, decimal, and initial supply, and of course the recipient. And eventually they will receive the initial supply. So we go up to storage variables. So you can see this is the name is of type fields, and this is of U8. So you can actually pass these values even at this end here, or you can do it here. Either way works. So let's do it within the inside like so. First thing we have here is name of our token. So let's call it session 3, right? Bootcamp session 3. But you can't just write session 3 because this is not a string, right? This is not a string. So we need a felt equivalent of session 3. And if we go over to the browser, I think I have Stack utils here that helps us now, convert things accordingly, right? So it's taking time to. All right, here we go. When doing this, whatever I say, hopefully I will get what I want. Okay, I don't know what is this. Okay, that's not what I was supposed to enter actually. All right, so I say I should go for session. Spell well. Yeah, you can. Session 3. Okay. So session 3, this is the felt equivalent of session 3. You can see that this is the hex equivalent, and string is also a string, like, yeah. So we copy this. Since what we are passing in is a felt, so we copy this guy, just click on it. For this two, let me just send it to us in the chat box so that we can copy and paste accordingly. So that's the guy here. In case if you're following along, if you're putting along and want to, that's it. So I'll copy this guy, the felt equivalent of what we want to use, and head over to my VS Code right here and paste it, right? So I paste the first value. This is only the first value. Remember, it's called session 3. And then the second one is also symbol. So the symbol, we can go with something like maybe we call it Starknet Africa. That's SA, right? SA. So this is the equivalent in felt. So we copy this guy, head over to our VS Code, paste it. So yeah, the next value is a U8. You can actually use U8, let's just use say 10. You don't have to convert. U256. Remember our U256, you can't just pass in a value like one value. It has to be two values, right? The high and the low. So we have to keep track of that as well. Now we are wanting to, like, let's say we are minting we want to mint say this is what we're looking at actually. We want to mint say 10,000 then 111. Okay. So this is the low or the high, then you have to add 0. So you must put the 2 in between. Then you make this, you get the vibe here. It has to be 2. If you use just 1, you get a compile, it won't actually work. It won't work. So the recipient, let's use the person deploying, right? So let's use this guy here, the account 1. Sorry, account 1, the one we've been using so far. So I copy this guy, that's 0973. And down here I paste it, right? I don't need to convert anything in this case. I think everything is in order. Hopefully we don't run into any error. This is the name of our token, the symbol, the decimal, the okay. Someone unmuted. Do you want to speak or yeah? Do you have a question, please? Okay. All right. So we have everything we need, and this is the receiver, the person that's going to receive the recipient. Okay. And we have our RPC, the account, and then the key store. So if I hit enter, I'll enter my password as usual. Go. Now we have a contract error. So what could this be? Let's see. Okay. Let's see. I don't know what well, somehow it works right now, but I don't know what could have been the issue before now. So, developers and bugs. So I'm sharing my screen one more time. Let's see what we get. Share. I believe you can see my screen at the moment. Well, like everybody's so quiet. Are we following at all so far? Please, I need some feedback. Like so far, before we got to the bug, I was kind of breaking our spirits. Are we like following so far up to speed? I need feedback, please. You can type in the chat box as well. Okay, thank you, Blessed. Another person, please. Okay, thank you, thank you. All right. So, okay, all right, thank you. Bug is part of the process, I guess. So sometimes things happen. So, according to what I have here in my, I don't know, I might take this out. Chat to close your group. Okay, yeah, it's closed. So, according to what I have here, I didn't actually do anything different. I just like this thing what they call my view. I just like declared what we have earlier, the same process, right? And it says already declared, right? So I grab the same guy and then impute it here. You can see what I'm saying. I'm showing you right here. So it works and it got deployed. Now, has anybody been able to deploy so far, please? Like, I need feedback on that too, so that I know I'm not on my own. So if you run it, so think, and we have 883, with the same contract address with what we have here, so it changes. So I think we have what we need right now. And so please, has anybody been able to deploy to Katana so far? Yeah, I need feedback. If you're facing any challenges, we tackle it together. That's why we're here right now. And I will still have some other things to do before we call it a day. Delegate calls. I'm waiting for a feedback, okay? Right, one person. Not yet. Most of us are coding along. You ought to have like, I thought I dropped the repo. Right? Is it not on the chat? Okay, yeah. Thank you, Francis. Yeah, I dropped it here. So coding along like was going to take much of our time. That's why we decided to like prepare ahead of time. So apart from my guy here that's coding along, has anybody been able to like get to this extent that I am? Please let's talk so that we. Okay, make dad. Where exactly are you lost? Okay, what exactly is the issue you're getting? And what's the OS you're using? That's Team. Timothy, are you using Windows? Require. I'm not just flowing the process. Okay, that means you're not coding along. Okay. Team, are you using Windows or Ubuntu? Okay, Ubuntu. Wow, I've not seen this particular error before now. Katana. Okay, are you using the coil command or you're using the one that to compile? You know, we have two methods. You can either use the coil, right? Or you can use okay, use the other one, try compiling, because even myself when I installed, I used I compiled from the GitHub. Yes, use that one, it should work. Although it might take a while, but I believe it should work. Yeah. So use that one. Hope you have access to our slides. I think it's on slide what? Invoke Katana. Yeah, so you can just make a directory, your home, and then yeah, code works for some people, but it doesn't seem to work. That's why we have like two alternatives. So you can use this, then CD into that, then clone, CD into what you just cloned. It's very, very basic. And then you install. This might take a while actually, depending on how the strength of your PC. Okay. So after this, we'll be able to install like deploy our ERC20 token to Katana, right? So if we look at what we have here now, so everybody is now happy all of a sudden. And then so if we can, another thing we can do now is try to interact with the token we just deployed, right? And one of the things we can do is we invoke and then call. So I believe we going back to our cheat sheet, that's down here. So it's I gave the command is here. So we have to make a call like so. Copy, go back to VS Code, and well, we paste. Now we have to put our contract address. So we see how it works. Starknet call contract deployed to, that's the address. So you can see it, the contract will be deployed at this address here, and this is the same thing. So we come back to our command line, and we put, okay, sorry, what did I just clean now? Contract address should be this guy. We can always go back and get it, no worries. So we put this guy, that's our contract address. And okay. Next thing, we're almost done actually, so no need. Starknet, we have the command. Then next thing we have to do is get the function. Let's try getting the name of the token. Remember we named it okay, I think I changed it after a while. This will be something else. So this is the token name. Remember, within the external block, we have the functionalities that we can call get name is one of them. So if I copy this get name and I paste it here, yeah, get name doesn't take any parameter, right? So everything should be okay. Hopefully, I click enter, and we were able to retrieve something, and that's the name of. So if I go, let's see what that means. I use this guy. We're using this guy earlier, but I had to change it to something else. So you can see the name of the token is this. It's called a daisy. When I was just trying to something out, and that one works. So why did I change my cursor, please? Okay. Okay. Take this off. That means you. So if we want to get maybe something else, say another command. Okay, let's see the balance of balance of our the guy that received it. I believe he is the first address. So let's go all the way to the top. That's this guy here, 73. He's the one that received it. Then we come down to this point. Deploy the receiver, yeah, 73 is one that received it. So we paste, we just bring down the code we had earlier, and we, instead of using, okay, we're still getting balance of is also a read. So we go back and then instead of using get name, we put balance of, right? And hopefully there's no typo there. Else we just copy and paste that in, you know. So we are trying to get balance, paste it, and then hit enter. Okay, we got another contract something error. Let's see. Let's copy this. Okay. Let me copy. That's balance of. Okay, balance of, actually, if I'm taking balance of takes like an address, right? And I didn't put it. Terrible. So sorry about that. If I go back all the way to this guy is meant to be our contract address, which we have down here. Wasn't meant to change at all. Yeah, we copy our guy here and then go down all the way to this place and paste it. Yeah, give a space. Then balance of takes a parameter, that's an address, and we're trying to get our own balance, the one we deployed with, and that is this guy here. Okay, let's copy this and paste it here. And then okay, let's run and see what happens. So you can see what we have here. We have something, and then that's the low and the high. Remember how it works is U256, right? No, 256. So we got this, and if you convert it using our tool, let's see what we have. Paste. So we have 10,019 like we stipulated before now. So you can also write, right? I think the command is even in our this guy. The difference between this and this now, you know, call and invoke. Here you have to use account, you know, the person that will sign the transactions. That's just the difference. And they call the function name. If it has argument, you pass in the arguments, just follow the same procedure and the contract address, and you get this. So next thing we have to try out is you know, dispatch, you know, dispatch. If I go over to, yeah, we're almost done. So go back to this guy, this other place. I think we can actually navigate everything from here. So we have a dispatcher. Now, like I said earlier, the difference between dispatcher, that's contract dispatcher, and then the library dispatcher is just that with a contract, you're interacting with what is it called? A contract address. While with library, you're interacting with the class hash. Okay, class hash. So if we open this guy, let's see. So right here we have our interface, and just like from the ERC20 we already created, and then we have a second contract here that's called token wrapper. Now look at the interface we are using. This line 40, line 41 are generated automatically for us by the compiler, right? And then this other guy here is the interface from here. You know, so we have two interfaces in this particular contract. And then right here, we have our storage, then we have the implementation, which implements the functionalities we have here, all right? So you can see where the contract address comes into action, right? And say get name. And this passed in, you can see it even here. We have just two functions, get name, get token name, and transfer token. So this contract here, that's token wrapper, is making a call to our ERC20 token, you know, the contract we have before now. So how to do this, you have to deploy this guy as well. So to deploy this, we head over to cd into this par, right? Okay. Okay, I'm in the wrong place actually. Let me open another terminal so that we separate everything. cd into this bash here. So ls to make sure we have everything we need. And we also have to run every single command we've run before now. And that includes creating a file. First of all, we have to build scab, scab build. Okay. All right. So we build and it compiles. And after that, we create a signer like we did now, right? This guy, now we are going to use the second account from what we have here. That is this other account to deploy this. So we use this private key, copy, go back to what we have. We not this terminal, this one, and we paste it here, right? Like always, you enter your password and it gets generated. You know, we have this guy up here. Next thing we have to do is what? Is generate the signer. You don't have to cram it. Go back to what we have here. We've generated this guy. So next thing is to fetch our account. So we go down to this place, fetch our account. Okay. So instead of using 7.3 now, we change it to that is 855, right? Yeah. Copy. So we're almost done. We're almost done. This guy, we're fetching the accounts. So we paste and then hit enter. It gets generated for us. So right now we have the two accounts and our key store. Next thing to do is what? We declare, right? We declare the contract using this. So we go back to our VS code. So to declare, we need what again? To declare, we just get the targets. And if we go to our targets folder, you'll be able to get something, you know, the Sierra, the file parts, contracts. This is the artifact. Okay, this is the guy we want. We copy the relative parts and come down here, go down all the way to this place, and then we replace it with what we have. I paste and yeah, so I did make necessary changes and then I hit enter. This guy, okay, we've declared the class hash. So now it's time to deploy. You can see this guy don't have any what's it called? Any constructor. The contract we have, it does not have any constructor. So yeah, I think it makes our life a lot easier somehow. So we go to, this is the class hash we are deploying, guys. So copy it and then come down here. We replace it with okay, maybe I should just clean from here. Don't need these variables. So I just trying to make a delegate code to our to the second contract we have and see what happens. So this, we put our contract class hash here. And this contract hash is what I just inserted here. What else do we need? That's if there is constructor, then we have to input constructor. But I don't think we don't need anyone. So if everything goes to plan, let's see. Hopefully don't get into another error. All right. This time around, we're able to get this up and running on the first try. So to now interact with this, all we have to do is we can, token name, right? I will pass in the contract address. This contract address is the contract address that we got from this guy here. The ERC20 that we deployed, that's this particular guy here, A3. So, okay, I have a shot. That equation. Okay. Okay. All right, let's go to the bits. You can see that. That's the repo here. So, yeah, that's the repo here. So after this, come on. After this, we just head over to this guy, and then we say we use our stackline again, stackline call. After call, we pass in the contract we are trying to interact with. That's this guy. We take it up and then we copy, right? Copy, we paste right here. Next thing to do is what? The function name we are trying to interact with, and that is token name. So I copy token name, I paste, and then you can see token name takes a contract, like a parameter. That's contract address. So we have to pass in an address. And that address is the address of the ERC20 that we just deployed. And that's this guy here. Okay, copy it, go back to where we are. I paste this guy. And then of course I grab my RPC because that's the pointer to Katana. Okay. Wow. No, I don't want to copy multiple stores, please. Let me paste it here and edit accordingly. Yeah. So if I go up, I'm on this thing, make it work. Okay. Cut you off, come down here. I specify the flag, that is the RPC, and then I paste what I have with me. Hopefully everything will work. We're trying to get the contract name. So I copy this, go back to our utils, so we are meant to get this same value. That's our contract name. We called it Adese, right? So let's see. And yes, we were able to get it. Now, I believe this is actually straightforward. Just get stackline call, the contract address you want to, that's going to make the delegate call, right? And you have the function name. This function name is made possible because of this trait here. The trait here exposes every single function within the ERC20 token, like all the functionalities there, it exposes it. So it gives you access to it, and then you pass in the contract address. That is second contract. This guy here and this guy here are two contracts that are interacting, and we're able to retrieve the name of our token. I think at this juncture, we will be calling it a day, unless someone has question, and then we can, yeah, I'm already there. So unless anybody has any question at this point, this is where we stop for today. So now for the other guy, that's library, all you have to do is instead of using contract address, you use the class hash of ERC20, right? Use this particular class hash here. Let's go up a bit. I think we have it somewhere up above. Yeah, you use this guy and you still get the same result. Like, okay, I have the code here. Let me just like expose us to it. But we won't have time again to like to run the interaction live here. So we have this, just another ERC20 with some implementations. And then we are see the get name, it accepts a parameter class hash, which is of type what? Starknet this. And then here you pass in the name. Once you call this function and you pass in the class hash of our ERC20 token, you get that name again. So the difference between the library dispatcher and the contract dispatcher is in contract dispatcher, like we have seen here, we had to interact with a smart contract, like smart contracts. And while in with library, you use class hash. Okay, I think that's about that. Thank you for coming around. All right, Paul.
Yeah, thanks so much, man. That was good. I mean, the bug kind of like tried to run our day, but you
Yeah,
overcame
yeah,
it.
yeah, 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 yeah. It's part of the process, actually.
Yeah, sure. Yeah, thanks, man. So we had someone talk about using Starknet Foundry like today. But that aside, for the next call, for the next section, is going to be testing, right? So we are going to do the testing on Starknet Foundry. So Timothy, if you are still here, kindly have in mind that by next week Thursday, in the next section, this is section 4, would have a look at Starknet Foundry. And to everyone that made it to this last minute, I really appreciate your presence here. And at the end of this bootcamp, we are going to have a chat with people that are graduated, then also have a section with Stagnant Foundation for everyone that graduated for this Cairo Bootcamp. And yeah, we also plan to have we also plan to have a particular session whereby we'll show people how to use only those. So when you are done learning, probably you might start contributing, but obviously it will take a little more time, right? But yeah, that's actually part of the process. And yeah, I think this is it for today. And thank you so much, CC, for today's section. And yeah, and do have a lovely night, man. Good night.
Yeah, 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 yeah. Take care, bro. Take care.